Hello, my name is Hongjun Zhang. I'm from University of Liverpool. I'm here to present our work. Host line imaging becomes an important application in digital pathology. A host line image usually has a very large resolution. Therefore, host line images is well known to be hard to process, expensive to annotate, and requires a large amount of storage. Also, there are very limited numbers of host line images in a cohort. All these factors make it challenging to develop machine learning models for host line image analysis, and researchers resort to weakly supervised approaches, especially multiple instance learning. In multiple instance learning, a batch is a group of instances. An instance is either positive or negative. If at least one instance in a batch is positive, then this batch is defined as a positive batch, otherwise it's a negative batch. In training, only the batch labels are available. Multiple instance learning is a useful tool for the weakly supervised classification for host line image, where a slide is seen as a bag, while the patches code from it are the instances. However, developing multiple instance learning models for host line image classification faces great challenges, especially that there are usually a limited number of slides in a cohort. There are two main contributions in our work. First, we propose to derive the instance prediction under the framework of a prevalent embedding-based multiple instance learning strategy, attention-based multiple instance learning. Second, we introduce the concept of the pseudo-batch to alleviate the negative impact introduced by the innate characteristics of host line imaging, and then propose to build up a double-tier multiple instance model upon the pseudo-batch. Here shows two fingers. Finger A is the illustration of the learning-based model for image classification, while finger B is the paradigm of attention-based multiple instance learning, which is the base of many embedding-based multiple instance models. In our paper, we prove B is a special case of A. This conclusion enables the utilization of the mechanism of grade CAM on attention-based multiple instance learning, and we present the corresponding expression of the derived instance probability here. We show the overview of the proposed method here. The patches from a slide are randomly split into multiple smaller bags, assigned with the parent bags label. We define such bags as pseudo-bags. In this way, we virtually increase the total number of bags. Then the tier 1 multiple instance learning model is applied to the pseudo-bags. However, it is possible that noise labels are introduced in some pseudo-bags. Therefore, we distill a feature from each pseudo-batch according to the tier 1 model's instance results, and apply a tier 2 multiple instance model to the distilled feature for the parent batch prediction. The heat maps show the detection result from an attention-based multiple instance model. We can see that the proposed derivation of instance probability provides more consistent, more contrastive heat maps in comparison to that of the attention score. We can also observe that not all activating regions by the attention module correspond to positive regions. However, the proposed derivation can still better recognize them as negative. We evaluated the proposed DTFD multiple instance learning onto public histopathology host line image datasets, namely Cambodian sitting and TCGA lung cancer. We can summarize from these results. First, the proposed method outperforms other shorter methods significantly on these two datasets. Second, DTFD multiple instance is more robust to the sparsely positive slides, where the positive region only occupy very small proportions. Third, selecting the most positive instance to represent a batch is not always the optimal choice. Here comes the conclusion. First, the derivation of instance probability in attention multiple instance learning is a better approach than the attention score for positive instance detection. Second, the proposed DTFD multiple instance learning provides a new perspective to solve the multiple instance learning problem with superior performances. Third, we expect that the derivation of instance probability will be served as a useful tool for developing related multiple instance learning model or for the related analysis in future work. Thank you.